Hello, my dear students. With you, Mr. Mahmoud Askar. We will study today geometry section at Unit 5, lesson number 5, properties of the cyclic quadrilateral. We'll study new theorem, talk about the cyclic quadrilateral. If ABCD is a cyclic quadrilateral, then each two opposite angles, their sum 180. Measure angle B plus measure angle D equal 180, and also measure angle A plus measure angle C equal 180. In a cyclic quadrilateral, each two opposite angles are supplementary that their measures equals their sum 180 degree. Okay. When we write the proof, we will write since ABCD is a cyclic quadrilateral, therefore measure angle A plus measure angle C or measure angle B plus measure angle D equals 180. Corollary on the theorem. The measure of the exterior angle at a vertex of a cyclic quadrilateral is equal to the measure of the interior angle at the opposite vertex. Note in the opposite figure, CBE is an exterior angle of the cyclic quadrilateral ABCD. CBE is exterior, okay? Then this exterior equals the interior opposite to the vertex B. Opposite to the vertex B, then it's equal measure angle D, yes. Then if since ABCD is a cyclic quadrilateral, therefore measure angle CBE equals measure angle D. Okay? This is an corollary. Another corollary or converse of theorem 3. Converse of theorem 3. If two opposite angles of supplementary of a quadrilateral, if two opposite angles of a quadrilateral are supplementary, then their sum 180, then this quadrilateral is cyclic. Let's consider measure angle A plus measure angle C equals 180. For example, 90 or 100 and this is 80, or 70 and 110. If any two opposite angles, the sum 180, then the shape ABCD is a cyclic quadrilateral. And the corollary say, if the measure of the exterior angle at a vertex of a quadrilateral is equal to the measure of the interior angle at the opposite vertex, then the quadrilateral is cyclic. And this converse and this its corollary to prove that the shape is cyclic quadrilateral. Let's think about example 1. ABCD is a quadrilateral. ABCD quadrilateral. Inscribe it in a circle. We said before that ABCD, yes, is a cyclic quadrilateral. This is the meaning of the first sentence. Measure A equal 70 and E belong to the ray AB. CD equal CB, two chords are equal. DB equal DA, two chords also are equal. We want to find measure angle EBC. Measure angle EBC. Let's think. To get the measure of angle EBC as he wants in the example, this is an exterior angle of the cyclic quadrilateral. Then it's equal to the angle which opposite to this vertex. Then it's equal to measure angle D or CDA, all of it. Then we must get the measures of the two angles and get their sum. Okay, let's say this is x and this is y. How can we get the value of x? Okay, first, this is an isosceles triangle. Then the base angles are equal, 70, and this is also 70. This is the third angle inside the triangle from 180. It's so easy. And also here, how can we get the value of y? ABCD is a cyclic quadrilateral. Then each two opposite angles the sum 180. Then measure A plus measure C equals 180. Then measure C equals 180 minus 70 equals 110. When we get 110, y, and this is also y because this is an isosceles triangle, then y equals 180 minus 110 divided by 2 because we have two equal angles unknown. Hence we get x and also y. X plus y is the same measure of angle CBE. Then first, let's write the proof. Since DA equal DB, therefore measure angle, this angle ADB, or we can say x. We can say x equals 180 minus 70 plus 70. It will be 40 degrees. And also, since ABCD is a cyclic, therefore measure angle C equals 180 minus measure angle A. It's measure 70. 180 minus 70 equals 110. Then measure C 110. And since CD equal CB, therefore measure angle CDB, it's denoted by y, as I said before, equals 180 minus 110 divided 2. It will be 35 degree. X equal 40, y equals 35. Therefore, measure angle ADC equals 40 plus 35 degrees equals 75 degree. And since this angle require ABC, angle ABC, exterior of the cyclic quadrilateral ABCD, therefore measure angle EBC equals measure angle ADC, and we get before measure angle ADC equals 75. This is the solution of example number 1. In example 2, in the opposite figure, BC is a diameter in the circle M, A belongs to the arc BC, and DE perpendicular to BC. Perpendicular means the angle between them at x equal 90 degree. It's a right angle. We want to prove that ABXY, and this is a point Y. We want to prove that shape is a cyclic quadrilateral. When this shape is cyclic quadrilateral, if two opposite angles, the sum 180. If two opposite angles, the sum 180. There is one angle in X. Where is the opposite? Inside the shape. It's A. if A plus X equals 180, or if measure A equal 90, it becomes 90 and 90. 90 plus 90, 180. If that satisfies, then ABXY, this shape becomes cyclic quadrilateral. Okay, it's so easy. We studied before that. Inscribed angle. Inscribed angle as A. Okay, drawn in a semicircle. It's right. It's right. And it's measure 90. Okay, let's write the proof. Since CB is a diameter, because it's this diameter, okay, make the angle into two semicircles. Therefore, measure angle BAC equals 90 degree. And because of measure angle BAC plus measure angle X or YXB, 90 plus 90 equals 180. They are opposite and supplementary. Therefore, XY, this shape becomes a cyclic quadrilateral, and hence we have finished our lesson today. Thank you for listening, and I'll wait your questions, okay, and wait me inshallah in the next lesson with you, Mr. Mahmoud, and we will complete the next lessons inshallah. Thank you for listening.